Okay, so the last part asks us to use graphs to describe the characteristics of the combined functions, h of x and k of x. So we're going to look at the symmetry, the max min values and whether they exist, the intervals of increase and decrease, and then the zeros and the range as well. Okay, so let's take a look at the actual graph that we had previously, and I'm just going to fold the page so we can look back and forth. Okay, so starting with symmetry. So in terms of symmetry, we want to see whether the function was even or odd. And so if we look at our original function, so the blue graph was the cosine function. You'll notice that the blue graph is symmetrical along the y-axis, so that tells me that this function is actually even. And if I look at the red graph, which is the linear function, you'll notice that it's actually symmetrical about the origin, which means that this function would be odd. So, because we are combining an even and an odd function, what I'm expecting is that the combined functions, either through addition or subtraction, will end up being neither even or odd. Okay? And that's because one function was even and the other one was odd. And so if we look at the green graph on the sum and the difference functions, you'll notice that it's actually neither even nor odd. You might think maybe it's an odd function. However, if you look closely, it's not symmetrical about the origin. If I rotate it over 180-degree rotation, the graph will not overlap. Okay? So in this case, we have neither even nor odd. So there is no symmetry because one function was even and the other function was odd. So you end up having neither for both h of x and k of x. Okay, max and min values. So because the original function cosine function that we're looking at for f of x, because there were local maximums and minimums in the cosine function, even though they didn't exist for the linear function, the combined functions, whether we were adding them together or subtracting them, end up having local maximums and minimums as well. And you'll notice that the local maximum is slightly off from where the local maximum was before, and the local minimum is slightly off from where the local minimum was before. And that's because you combine two functions, so they won't necessarily be in the exact same place. Okay, so maximum and minimum values, local max and min exist, and that's because they existed for the cosine function. Okay, next part, intervals of increase and decrease. So you'll notice that there are several intervals of increase and then several intervals of decrease as well. So if you look at the graph, you may think, hey, the graph is always increasing, but it's not. It's increasing up to the maximum, and then it decreases, and then increases again up to the maximum, and then it decreases, and then increases again up to the maximum, and then decreases towards the minimum, etc., etc. Same idea for the subtracted function or the difference function. There's an interval of decrease, then an interval of increase, then an interval of decrease to a minimum, and then an increase to a maximum, and a decrease to a minimum, increase to a maximum, and then I think you get the point from there. Okay, so the intervals of increase and decrease do exist. Because there are so many, I'm not going to list them all, but I generally just wanted you guys to get an understanding of the fact that if you have several local maximums and minimums, then you can expect to have several intervals of increase and then intervals of decrease as well. Okay, something for you to think about there. Okay, zeros. So let's take a look at where the graph crosses the x-axis. So we discussed the intervals of increase and decrease already. And again, like I said, I'm not going to list the intervals because there are so many of them. I just want you to get the general idea of it. So let's take a look at zeros. So let's look at where the graph crosses the x-axis. That's essentially what a zero looks at. So there is the point where the graph crosses the x-axis. Same thing here. And if you actually look at both the graphs, one is on the negative x-axis, the other one is on the positive x-axis. Now, how did that happen? Well, on the subtraction graph, in order for f of x minus g of x to equal 0, what that means is the value of f of x and the value of g of x have to be the exact same. And so if you actually look at the graph, the red graph and the blue graph intersect at this particular value of x, which means they both have the same value of y, and so the same value of y for f of x and g of x, if you take them and you subtract them from each other, you end up getting 0. So let's say this is about 0.7, this is 0.7, minus 0.7. Both of them have the same value, which ends up giving you 0. So, in a difference function, what you're looking for is the point of intersection between the two graphs. Wherever the two graphs have a point of intersection, that's where the 0 of the function will be. Okay? And that's because they have the exact same value of y. If you subtract the same value from itself, then you end up getting 0. Now, it's a little bit different in the addition function. Okay? In the, or the sum function. What we're looking at is f of x plus g of x equal to 0. And so what we need is the value of the y has to be positive in one of them and negative in the other one. It has to be the same value of y but positive and negative. And so if you actually look at the 0 on the green graph, you'll notice that the cosine function is about positive 0.5 and the linear function is about negative 0.5. And so positive 0.5 plus negative 0.5 equals 0. So in the addition function or the sum function, what you're looking at is the same value of y but positive and negative. In the difference function, you're looking for a point of intersection because both the values of y are exactly the same. Okay? So there's the 0 of the function for h of x. We have x equals, I would say about 0.7, negative 0.7. And for k of x, that's the difference graph. We have x equal to positive 0.6 approximately. Okay, in terms of the range, now this is a little bit different as well. If you look at the range of the two graphs, the two original graphs, the blue graph, the range was between negative 1 and positive 1, whereas the red graph, the linear graph, it was all real numbers. And you'll notice that because there was no restriction on the red graph, you'll notice that the combined function also goes for all real numbers as well. So, the green graph sort of follow the same range as the linear graph. Okay? So, no restrictions on it. It's all real numbers because it continues from negative infinity to positive infinity. Okay? So, the range of the two functions are y is an element of all real numbers. And there you have it. So, there's the characteristics of the combined function summarized here. Okay, that's it. So there's your assigned work from your textbook. Make sure you watch the video for lesson 2 tomorrow and be ready to complete your homework in class for lesson 2 as well. Okay, that's it. Take care.